and welcome to GMBN Tech. Today we're answering all your questions, so if you've used hashtag Ask GMBN Tech down in the comments of any of our videos, then we've been able to find it and try and answer it for you on a show like this. And Isaac has the first question. I
do. This was submitted by Broccoli High Kicks, and they're saying, what side of the wheel should I start and finish fitting my tyre bead to? They've heard conflicting advice. I also received conflicting. I went through a bit of a revolution with this, ironically for wheels, and I completely changed what I did once when someone told me actually that you should finish at the valve, not finish opposite the valve, which is what I was doing. And this is because you want to give yourself as much slack as possible with the tyre bead if it's tight and you can't pop it over the rim. The valve, if it's tubeless tyres, the valve is obviously stopping that tyre sitting right down inside the bed of the rim. So if you pop it on first here, you get your tyre squeezed like that, all the way that, and it gives you enough slack, you can force it around, and then you can pop the tyre on. For tubeless tyres, a lot of the time that works great for inner tubes as well. Sometimes I find if it's a bit unruly, the tyre's really loose, and the inner tube is kind of popping out, if you sort of start it at the valve, because the valve is holding the tube in, and then you work your way around, and you might need to actually, once you've done most of the tyre, pop it off at the valve again, pop it on opposite, and get it on. If you've got an inner tube, that can help, but tubeless, opposite the valve to start.
But the key, get that bead into the centre of the rim, because that's like the smallest diameter, so it'll feel nice and baggy and easy.
Exactly.
Okay, my next question from Steve, by the way, who says, is it okay to store my bike upside down? Short answer is kind of yes, but it also depends on the brands and the systems that you've got on your bikes, because it can pose some negatives, but also some positives. So for example, your brakes, Shimano do actually specifically state not to have your systems upside down, because if there is any air trapped in, say, the lever, for example, once your bike is upside down, that air will start to rise through the fluid and end up in the system. So when you bring your bike back round the right way, you will have air in the system and it will feel very spongy and bad. And of course that can happen to any brakes, not just Shimano. So that could be a bad thing. And also there's suspension, which generally, actually, if I just use this as an example, might be a positive, because we have in an open air bath system, in this sort of air fork style, we have oil in the lowers here, and if you were to turn them upside down, all that oil is to end up sitting around the seals, which is the thing that we want to keep lubricated because it reduces the friction on the stanchions going in. However, if you've got a poorly maintained bike, then these seals, they could be baggy, you might end up getting some fluid leaking from the forks completely, which is a bad thing, but obviously it's bad that you didn't maintain your bike in the first place. So I guess the long and short answer, or the short answer after that long answer, is that yes, there can be some negatives, but generally in a perfect world, perfect bike, it shouldn't really affect it.
Next up, we've got a question from John Smith. Why isn't titanium used by pro riders? I'm especially thinking about titanium frames. I really hate that everybody jumped on the carbon fibre bandwagon. Key answer, I think a combination of factors really has led to titanium not being widely used for full frames in mass production. All of these operate within a market, and usually when things aren't common, there's kind of economic reasons behind it. I think titanium is expensive to make. You have to synthesize it these days using this thing called the Kroll process to isolate it all and make it, it's called CP, commercially pure titanium, which is what they use in aerospace. It is actually heavier than 6061 and 7075 aluminium by volume, but because it's stronger, you can use less of it, you get light parts.
It's more expensive.
It is a lot more expensive.
The labour as well is more expensive because you need skilled welders with titanium.
Yeah, exactly.
Carbon,
much more difficult.
Unskilled workforce.
Yeah, and carbon, it obviously is a derivative as well, and it comes from the petrochemical industry. It's plastics and stuff, so it's not brilliant for the environment, but it is super strong and readily available and cheap. So that's why that's kind of happened. I think titanium is really good when it can be 3D printed. It's direct metal laser sintering. That's what the Atherton bikes use for their lugs.
Yeah.
And you can make bits like that. But if you want to try and work, mould it into whole frames, I think that's much more difficult.
But that does actually prove that there is some pros on titanium, because the Atherton downhill bike's being raced. And also Nico Malali running CNC machined titanium cranks as well.
And we see people using it for prototypes like the pivot bike and stuff. It's just that mass production thing we don't tend to see. The 5-diff thing is interesting, because they have so much aerospace grade, commercially pure titanium. I think their bike arm of it it's like an offcut. You know, they have their expertise, their tooling, their supply chains, and they're able to absorb the margins that would be prohibitive for just a bike company.
Yeah, well, they get their money from sending stuff to Mars, so
exactly.
the rest of the bike industry can't afford that kind of tooling or material.
So overall, for those reasons, I mean, that's why carbon is always winning at the moment. You know, it's cheaper to produce, it's more readily available, and we are seeing it on the World Cup circuit a bit, but overall, that's why it hasn't been pushed out to the mass market or seen on lots of pro bikes.
Okay, my question from Joshua Sims says, what would be a better upgrade to a hardtail? Carbon wheels or something like carbon handlebars, seat post or stem? My bike he wants his bike to be a bit smoother and nicer. Personally, I wouldn't always go for carbon, especially if your goal is to make something smoother. I mean, trying to decode what you mean by smoother. If you mean you want a more compliant ride, a lot of carbon wheels and in fact carbon handlebars can be engineered to be performance oriented, quite stiff components, and so that wouldn't give you the compliance, it wouldn't give you a smooth ride. Certainly not what I'm thinking, smoothing out rough terrain. A big set of stiff wheels is probably not going to be your answer. So have you considered, if you want it to be nicer, some high-end aluminium wheels that do offer you some compliance? Or you could consider, if you've got the budget, maybe you've got an XC bike or a trail bike. Either way, there's a couple of options out there that actually use fusion fiber, which instead of using thermoset carbons, which has resin and it can be quite brittle, you can go for a thermoplastic, which actually has ride damping qualities because of the type of glue that basically bonds the carbon together. I would generally go for aluminium handlebars as well if this is a trail bike, because that does actually give you a bit more forgiveness as well. So I know that's a wishy-washy answer, but I don't know if you're riding trail or XC here. You've mentioned a seat post. Why not go for a dropper? Because regardless of what genre you are riding, trail or XC, switching out that rigid seat post for a dropper will just make wonders for your riding and your descending and single track capabilities.
Next question is from Quad. I was wondering if I'm able to polish my own parts for them to be silver. I want a new seat post clamp, but I can't get the one I want. I mean, you can. It's complicated. It depends on the materials. I think to do a good, safe, reliable job, you need to know what metal is there underneath, what it's coated in, how the chemicals behave, kind of what treatment is needed afterwards. It's quite complicated to do a job that sort of we can recommend safely. If you're a novice at this, I think recommend that you really research it, learn on cheap, small, non-load bearing parts in case you wear them out, because at the very least you're going to avoid your warranty. It probably stripping, powder coating and paint is a little bit more simple than anodizing. It's a place to start, and in any of these, I think the thing to really emphasize is that once you do end up with your polished part, to lacquer it with either 2K or some kind of lacquer to clear coat to seal that, because otherwise, depending on which aluminium alloy it is, it's probably going to oxidize again immediately, unless you have 720 like a Geometron, which is designed not to oxidize. But 6061, 705, like all of those will just discolor. They will also react with other materials on your frame, carbon fiber, steel, and it can corrode those.
And if you've been completely put off by the idea of going down this path,
be very careful.
Then, I mean, you can use a bit of manual labour, some manual polishing, maybe even thinking about like a brush. But then when you're using it on a saddle clamp, for example, do consider that you might be changing the tolerances on something that needs to have a good contact.
It's anything with threads or splines or faces, you know, anodizing it's only a fraction of a mil thick, but that will change it. That could cause it to creak if it's your crank splines, for example. On a seat post clamp, you need that cam to work properly, so it's a really good point. Don't shrink it unduly. I've seen some polished seat post clamps I'm sure you can get one.
Okay, my next question is from Zach Parliament, who says, what is chain suck? I've heard the term used to refer to a few different things. I think it's just one thing. It's effectively is when your chain ring sucks your chain up into sort of, well, behind it or maybe into your frame effectively. But what is happening here is sometimes when your chain gets worn, then the pins inside start to get loose, and effectively your chain stretches. We call it stretching, but it just sort of sits into its rollers, and as a result it will wear these kind of grooves in your chainring, and as a result of that, these can sometimes be hooked effectively, and it will effectively pick up the chain as it goes around, and instead of it just doing a nice straight line, it will actually get picked up and hooked, and that is chain suck effectively. But that is all we've got time for today, so if you've got any burning questions after hearing these, then do use hashtag Ask GMBN Tech down in the comments right now, and we will try and find it and answer it on a show like this in the future. But bye for now.